All right, numbers 12 and 13. Number 12, they're actually very similar questions. They're just different numbers, really. The data models the approximate height in feet of an arrow every second. Write a quadratic model for the situation and estimate the height of the arrow after 8 seconds. So they say write a quadratic model, not see if it's quadratic, but write one. So we got to start finding our differences. So 24 minus 4 is 20. 41 minus 24, that's what, 10, 13. 50 minus 41 is 9. 50 minus 5 minus 50 is 5. 53 minus 55 is negative 2. Let's do it again. 13 minus 20 is negative 7. Sorry. 9 minus 13 is negative 4. Yeah, that's right. Yeah, that's right. 5 minus 9 is negative 4. Did I do that right? Yep. And negative 2 minus 5 is negative 3. So those are a little awkward. They're not that well placed. But it is what it is. And they tell us to write a quadratic model, so we are going to average our second difference. We're going to average that second difference together. So we're going to do, for our average second difference, that's negative 7. Negative 7 plus negative 4 plus negative 4 plus negative 3, and there are 4 of them, so we will divide by 4. Negative 4 plus negative 4 plus negative 7 plus negative 3, enter, divided by 4, and we get negative 4.5. So that is our average second difference. That's what we're going to use for our second difference, that one right there. So, here we go again. A is your second difference divided by 2. So negative 0.45 divided by 2 is negative, what, 2.25? Yep, negative 2.25. Your B value is your first difference, your very first difference, which in this case is, remember, the difference between the starting point and the next point. So in this case it is 20. So we're going to take that 20 and subtract our A. So 20 minus negative 2.25. So when you subtract a negative, you're really adding, so that's 22.25. And last but not least, C is your starting point. So when X is 0, Y is 4. So we have enough information. Let's write our equation. Y equals A, which is negative 2.25, X squared, plus B, which is positive 22.25, times X, plus 4, which is our C. Okay, so there's your equation. That's like 90% of the problem right there. Then the instructions say estimate the height of the arrow after 8 seconds. So remember, seconds, that's our time, that's our X value, so we can just plug 8 into our X's. Remember, plug it into both. So after 8 seconds, if I take negative 2.25 times 8 squared plus 22.25 times 8 plus 4, I get the magic number of 38. So after 8 seconds, I expect this to be 38 feet high. Because the height did say it was in feet. I'm not going to worry if you don't put the feet on there. But anyways. All right, number 13. Go ahead and try number 13. Number 13 is very similar. Go ahead and pause and try it. But if you're not, here we go. A store opens at 6 a.m. The data below shows the number of people in the store every hour after opening. Write a quadratic model for the data and estimate how many people are in the store at 3 p.m. Okay, so write a quadratic model and estimate the number of people in the store at 3 p.m. So, here we go. 95 minus 50, well, that's 45. 135 minus 95, 9, 10, 11, 12, 13, that's 40. 171 minus 135, I don't feel like doing that in my head. Minus 135, I think that's what, 34? 36. I went the wrong way. 36. 201 minus 171. 201 minus 171, that's what, 30? Yep, that's 30. And 235 minus 201, that's 34. Okay, let's do it again. 40 minus 45, well, that's negative 5. 36 minus 14, that's negative 4. 30 minus 36, that's negative 6. And 34 minus 30, that's negative 4 again. Okay, so yeah, the second differences are actually pretty close. So if they want us to make a quadratic, which they tell us, they write a quadratic model. So, here we go. Y, not y. The average, we're going to take those, so that's negative 5, plus negative 4, plus negative 6, plus negative 4, and we're going to divide them all by 4, because there are 4 of them. Do not divide this by 5, or do not divide this by 6, because there are 6 points. Do not fall into that trap. So, I think it's like 4.7 or something like that, but let's try. Negative 5 plus negative 4 plus negative 6 plus negative 4, enter. Divided by 4 is 4.75. Well, negative 4.75. I was really close. Negative 4.75. That is what we're going to use for our second difference. Okay? So, the other thing we need, so for the first things first, we got our A value right there. So A equals negative 4.75 divided by 2. And we get 2.375, so I'll round negative 2.38. Negative 2.38. Cool. The B value, well, we need our starting point in our first difference. And it is 8 o'clock here in the wide, wide world of Mac. So here we go. To back up 1, to get to 0, we need to back up. We need to find our second difference. That's what, 4.75? Negative 4.75. So it's really going to be 45 minus negative 4.75, which gives us 49.75, which we're counting people, right? So I'm going to go ahead and write 50 because we're counting people. 49.75, I'm going to round to the whole number. And 50 minus 50 is 0. So we're going to say C is 0. We're going to say C is 0. And the very first difference is 50. So B and C. We said C was 0. My very first difference of that was that 50 over there I circled in orange. Minus my A value, so minus negative 2.38. So that's really adding. So my B value is 52.38. All right. So we got enough to write our equation. Y equals A value negative 2.38x squared plus my B value 52.38x plus my C, which is 0, so I don't have to write it. Okay. The last bit they say, how many people in the store at 3 p.m.? Well, your instinct would be to write in a 3. But remember, we're starting at 6 a.m. So this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12. I need 1, 2, 3 o'clock, so that's 7, 8, 9. I need to plug a 9 in for x. Okay, if you see something like this on a test, remember, check your units. Ooh, I still says month right there. That is incorrect. That is what hour it is. Okay, typo, you can live with that. And that is not balance, that is number of people. Oops. Alright, so we found out it's 9. 9 corresponds to 3 p.m. So we're going to plug a 9 in for both of our x's. So y equals, let's see here, negative 2.38 times 9 squared plus 52.38 times 9, and we're going to get some 278.64, which, yeah, I know that's half a person, 278.64, but we've been rounding to decimal points, so we'll just leave it at that. Cool. Have at it.